Hi everyone, my name is Hasanein. I work from Khafaji. Today I'm going to talk about very common development methodology. It's TDD, test and development. Despite that, I'd like to just ask a couple of questions. So, how many people haven't actually heard of TDD apart from the data? Okay. So, how many people actually actively developing TDD? By actively means really writing a test prior to any single line of code. Hands up. Liars. Okay, so hold up. How many people can't really remember how was it like to program without writing test? Okay, that's a tough one, but we've got to think about it for a while. How many of you guys actually enjoy writing a test? And the rest just hate it. So, the nature of most of the software development projects. We start with some uncertain specifications. We develop, we have lots of stories, in and out. The end of the day, it's the release day, we want to deliver, and oops, somewhere we missed a piece. We missed an important part of the system that we didn't think of. Or it might happen that we could actually develop certain features that we don't actually need. So as software professionals, what we actually strive to achieve it all the time is one thing. Simple. Clean code that works. What we want. Modular, clean, nicely designed piece of software that actually does what it's supposed to do. But how do we actually approach that? So most of the time, we start with, traditionally we start with a big design up front. We got all the different sexy design patterns that we could think of. Get this observer here, get that command here, get whatever stays in there. And that we have our own big design, implement it, start, finish, done, all's good. Does it actually work? We don't know. Then we start testing, debugging, and start all that nightmare. An interesting thing happens if we could think of this as a two separate projects. So we need to have clean code that works. So we tackle each one of them separately, but the order actually matters. So if we start with getting our code to work first, no matter what, just comments all the sense, get hard-coded numbers, well, anything, nested with statements, switches, well. But the aim is to get your code to work. Once that is done, tackle the cleaning up. So, someone said that clean code that works actually out of reach of even the best programmers some of the time, and out of reach of most of the programmers most of the time. So, what's the benefit of having unit test? So, just before that, does everyone knows what a unit test actually is? What are we trying to test with? A unit test? Hands up if you don't know. Okay. So, what's the benefit of having unit test? Can it provide the developer with an early feedback of what you're writing? The code that you're writing doesn't actually work. You don't need to wait until you deploy that to your system and test it in production or anywhere else. You have an immediate feedback just a fraction of a second away from the time you write it. You write it, run your test and see if that does what it's supposed to do. Test is a learning tool. So most of the time, as developers and myself, I don't really completely understand the technology I'm working on, but I learn as I go. So I consider testing and writing tests for the software I'm working on is kind of a guidance for me, something that could guide me in the dark if I'm working on a system with a lot of uncertainties. And tests are actually the first line of your code. So instead of just you writing your code and waiting until you run it as part of a complete integrated system, having a test that stands along the side of your code and acts as a first line of that piece of software. Do you guys write documentation? Do you comment your code?
I do.
You do? A lot?
Shame on you.
Do you think that's a good thing?
Honestly, I just write stuff for myself memory because I heard that writing too much is bad, but I tend to refactor a lot. So
yeah.
Sometimes, because I found that sometimes my comments get out of date.
Yeah.
So yeah, there is a hard balance. You're completely right. It depends. Sometimes, sorry, I'm talking too much. Once I was explaining how I figured out like the angle between two vectors.
Yeah.
I drew like lots of comments and I drew a triangle and stuff.
Right.
And one of the like genius programmers I was working with, he berated me for it. Like,
okay.
I struggle with maths. So is that a good or bad thing? Or is this off topic?
Well, if you think of it as you're writing the same thing twice, so if the code was clear enough to express about itself, why would you need a comma? Another way of thinking, streamlining the documentation, because people say that the code is the design, because everything you need to know about the code is in the code itself. So that is written properly, that written in an expressive way, that you don't need to comment, or you need a minimum amount of comments. So you could think of your code as an up-to-date, you think of your test as an up-to-date documentation of your code. Because if your code changes, the test has to change. It can never go out of date. This also gives us a rapid feedback about the quality of our designs. Because when we write a test, we imagine the best interface that we wish we could ever have. And we drive our way through until we got that complete bit of code. So that gives us a rapid feedback of how easy it is to work with our API, how fluent, how usable our API in terms of the interfaces and the services. And making code testable is inherently leads to a cleaner and more modular API. So, for example, if you have a bit of code you want to write a test for, you need to extract out the dependencies, inject them. That will lead to a more solid and cleaner piece of code. Test also reduces the number of bugs, like an order of magnitude, and also increase the development speed. So you eventually spend less and less time debugging. So one computer scientist, I always remember what he said. Called Dijkstra, he's the guy who invented the Dijkstra algorithm for the shortest path first protocol. He said, debugging is the art of removing bugs. Then programming must be the act of producing. Which is, in a way, it's true. Test leads also to decrease maintenance costs as the code is easier to follow and understand. Yes, first time you look into a foreign piece of code, most professionals will actually look for tests, they don't look for code. So one of the guys, Steven Smith, for example, is one of my colleagues, always ask me, what's this bit of code? What is the test? I don't read code, I read test. Just good. So, what does TDD talking about? So, what's the cycle of TDD? So, we talked about a clean code that works and that problem that we've broken down into two pieces. So, TDD cycle, typical cycle is writing a failing test, getting that test to pass in the cheapest and the simplest ways, and then clean up and write another test, and so on. So this cycle could go in a second, or in a fraction of a second, right? Very simple test, change the class, refactor, and so on. So that could be do. So the part where you actually tackle the that works problem is this one. So you just get your test to pass, get your code to work. Once that is done, then we work on the other part of the problem, which is making it clear. So, people maybe just refer to this as green, red and green refactor. So red as in failing test, green as in making it pass, and then your refactor. So what's the golden rule of TDD? Something that just sums it up is basically just never write any functionality without failing test. So, having a green bar means having a successful test or a passing test executes all sentence. What does that mean? Well, sometimes. So, think of TD as more of a steering process. So, for example, you're writing a test, having that test fail the first time, watching it fail, and then you think, okay, you have an obvious implementation to put in place. Just get that in, get your test to pass, refactor, and so on. If at any point in time you don't have an obvious implementation, some people follow, like, let's say, philosophy by Kenfek. What he says is, you get that test to pass with the simplest approach. So if, for example, you have said you're multiplying two numbers 5 by 5, then you just simply don't know how to implement it. Just return that 25. So you just hard code that. That is the most simplest way to get your test to pass. There's nothing simpler than that. And then you work your way through to generalize that and make it in terms of variables, not concrete numbers. But you follow that only if, I don't know if you don't agree with me. You only follow that in situations where you don't have a clue, you don't have a simple idea of how to proceed. But if you have an obvious implementation, which is how we work all the time, just get that in. So, another way of achieving TDD is triangulation, or meaning. Sometimes we write a test, but we don't have a way of figuring out the exact implementation. Then we go ahead and try to hit the problem from a different angle and write another test. So you'll have two different failing tests addressing a single issue. And your code, your implementation should make both of these passes. Some people say, okay, you should have only one failing test at a time. And you write just the code that enough just to make that test pass. And some other philosophies also say that, okay, compilation errors are failures too. So if you write an API and you still don't have these classes, you consider that a failure. So to make that pass, or to get from compilation failure to a failing test, compiling and failing test, you just need to, for example, create classes or interfaces, whatever, that you would work on. So, just little misconceptions about TDD. I tend to see most programmers talking about. So, people test very well and felt very thoroughly first time around. Second time, they tested it, you know, less than that. Third time, which test? Do we need it? Some people consider test as a boring thing, and it's just unnecessary amount of work. And say, hey, I write the code, I don't need to write test. Yeah, test doesn't write a test. And some people, okay, they accept the idea of testing, but say, okay, when we test a class, we should test just all of the methods. This class got 10 methods, you just write 10 and test that cover the whole class. So I consider this as misconceptions. So from this, talk about a little bit of some best practices. So what we actually test when we write a unit test, we test behavior, not methods. So we test the services offered by that class or module or software module, not the exact concrete methods contained within. And that should give you 100% everything. So each test should test only one and only one subject. So you shouldn't have two SUDs, two system under test in one single unit test. That's quite so one interesting thing is a very recent article on Kent blog. Does anyone doesn't know who Kent is?
Glenn Beck?
Kent Beck.
Oh, sorry.
He's the guy who brought TDD to life. So he's the author of the book TDD by example. So I think it's set the scene for the death of test-driven development. I think he works at Facebook at one now. So there's a recent article by Kent Beck coining a phrase called the one-on test. So if you go back to pick up any dictionary, so what the one-on, the word one-on means is that a sentence that composed of multiple parts, each of them could stand by its own. So he says that he sees sometimes a lot of tests that he calls one-on tests. What these one-on tests are, these are actually tests with multiple assertions. So you see a big test, we have assert this, assert that, assert that, we have tons of them in a single test method. There are what he calls as a one-on test and considers as an anti-pattern. So as a best practice, always have a single assertion. Well, keep them to the minimum. But I would prefer to have, because I write a single assert per test method. Keep it clean, precise, and small. And the test methods should be named in an instructive way. So your test as a whole should be readable, should be self-explanatory. Tests should be just speak for themselves. If someone comes even from not programming background or even not very familiar with the language, should actually understand what the code is supposed to do. Okay. That's not very. So, if you make developers communicate less, it makes developers avoid repeatedly testing. So what testing does simply turns programmers' fear into boredom. Just get this class, and that's it. So TDD negates fear. That's what can do. And if you haven't started TDD yet, I think it's a good time to start doing it. It's got nothing to lose but the bikes to produce. Thank you. Yes.
Hey, go back to your red green refactor diagram, please. So you started your talk talking about TDD helps you get clean codes that works.
Yeah.
Surely, if you follow what they talk about in red green refactor, then the most you'll get is ugly code that works, because the whole point of regular refactor is simplest code, and simplest code is ugly code. Simplest code is ugly code.
Yeah.
Surely, because you should be using design patterns just because, for the sake of using it, good.
Yeah, you should have a reason.
Therefore, doing regular refactor is ugly code that works.
Yeah.
It's not clean code that works. So where in TDD does it actually help you get clean code that works?
Well, I think the refactoring bit, because not only refactoring the piece of code that you just written. So in my opinion, you refactor the whole system that that piece of code fits in. So you could see there was a chance to implement, you listen to your code, you see your code, you see there was a pattern emerging that, let's say, I don't know, there was a chance to implement a command pattern, let's say. We have lots of different actions, and these could be encapsulated into 2 different classes and so on. So you just separate that. That fits in the refactoring part of the cycle. So you gain more, you apply your solve principles and getting these into more modular pieces, and you're still having your best to protect if you make any mistake along the way.
If someone's going to ask you a question next, it will look awesome to the crowd if they sat there. So it looks like you will get 500 points if you do it. Points, just prizes. VC money, maybe not.
Well, this makes me stop to mention imaginary. That's all.
So if I'm a
Come on, do it. Be a man. I'll relay your question and then see.
So if I'm awesome developer or self-contained, I know my software patterns.
Yeah.
So what's the difference between applying my software pattern first, then test it?
Hey, Hasanein, I have a question for you. So I'm also a developer, and I know lots of software design patterns, but I'm very experienced. On my principal level, level. So what's the difference for me to apply my testing first, rather than my informed software pattern, especially because I know the domain really well? Should have sat here.
You don't start writing a clean code from the very beginning. You write that code and clean it up. So how do you know that you needed that particular design pattern in the first place? You've got to have something in place, and you look into it and say, okay, this needs that pattern exists. I'm just make it more visible. Just make it cleaner.
Do you think a lot of it's to do with working with other people as well? Maybe you might know your craft really well, but when you start working like in a big company, you get lots of interns or people who perhaps come from the world of Ruby, and they don't no, but you get the intermix of different thoughts and ideas and languages as well.
And you make them talk. So, at the moment, where I'm working is I've been tasked to look into development procedures and processes, etc. I used to be a developer, I'm not a developer anymore. So I sit and I chat to the back-end boys at work, and I chat with them about their processes and what they do. I've brought up TDD to them in the past, saying, you know, how do I can implement this? Their response is, oh, it's not appropriate for what we do. How do I combat that argument? And how do I convince them that actually, if we go down TDD, they're actually going to hit their targets, they're going to get things done on time, they're going to, you know,
Well, what's the argument for not having TDD in place?
their argument is that it's not appropriate in a lot of CMS-driven websites.
Oh my God! That's just what we do. Well, it's a long story stuff. Well, the whole point, as you mentioned, having the test is to reduce a lot of frustration over the long term. So how would you know if you implemented some sort of, I don't know, a new feature that you haven't worked on something that you've already implemented, how you manage your regression testing? Along the one, after let's say 2-3 years of that project running, how would you know that that system still meets what the client wants? Is it the same system? People change code, could change the whole thing.
Yeah.
And that's better.
What CMS is it?
It's a mixture of cycle and code. Yeah. It's all got that sort of
So was it like a technical difficulty of having the whole TDD process fixed in?
Part of it, I think, is attitude, you know, sort of thought processes. Part of it's experience, part of it's clear, and I think part of it is thinking it's not hazardous at all.
I think first thing to start with is to educate developers of what TDD is and what benefit it brings. So if they hate it, they can't work with it. So they have to understand how it's beneficial for them, how it can help them in day-to-day life. So I think getting them into more TDD sessions, talks, trainings, but I think that.
Why do you call it TDD? Just because you were talking about describing the tests in terms of behavior, not testing method.
Well, if you test, well, I'm not talking about, I'm talking about TDD in its essentials. So BDD, it's just a different form of test-driven development. That one of the things. But what I meant by when you test a class, you pick up some sort of a Java class, let's say. You have lots of methods, some of them public, some private. Will you test the private method? What would you test is the behavior, what the class does. Let's say a class that retrieves some personal information from some HR database. So you test that this class actually gives you that service, not testing the methods one by one, environment by behavior. So you test the services offered by your module, not its internal content.
So I have my ugly code. I refactored it to help class to make it clean. Now, my original class will never pass in, say, a null and jump the code, sorry. So we can pass nulls. So it'll never do that to the code that's originally using it. But obviously the method can, and the method, that help method is a public method, so it's not private.
Yeah.
So I write a test for it to see how it behaves when it accepts null, even though in production we don't have it.
So you have this helper method,
Yeah.
and you don't check for nulls in that.
Yeah.
And you're saying that your code,
The only piece of code that uses it will never pass on code because there's a check there.
yeah,
But the actual code, that block itself, that actually extracts it to make it clean, does.
Well-
Just write a test for it.
well, if you always not returning null, there's no point of testing for it. For example, I don't know, you don't need to follow defensive programming if you always, as a development, I would say, convention, you don't pass nulls around. So if you have your null objects when you want to return nothing, then in that way you don't need to do defensive programming. But in a way, if you can't ensure that, then you need to make sure that that method behaves properly in case you got null by any of things.
Well, just comment on that question. I was thinking, if you think if you're never going to pass null to it, which if you do pass null, you expect it to blow up, yeah? If you pass null to it, you're going to expect it to blow up.
Maybe. I would say it runs a runtime exception, or maybe you're supposed to catch it.
So so maybe you actually wouldn't have to test that when you pass null to it, it does blow up. Because somebody could come along and modify that function, so if they pass null to it, it doesn't blow up. then changes the the underlying behaviour of your program. So perhaps you want to test, you want to let it test, when it behaves as expected, you want to pass an alter it.
Yeah, but it's just a difference of, well, if your production, how you're using the code, will never pass the code for it, because that's how you were using it.
If something might change the production code,
Right.
so then, and so it does pass an alter it, and perhaps somebody modifies the function so it doesn't follow that. So production code doesn't behave as expected.
Yeah.
So
So that's my point. If someone changes the behaviour of the production code, it's new behaviour, therefore there should be new testing. We shouldn't be treating the helper class as an API, because it's not an API, it's just extracted as a helper class. But yeah, that's the difference. Changing the behaviour of the application is different from the behaviour of a method, the core of the program that may not actually deal with it. Yeah, there's a slight difference there. Of course, there's always a chance that the person that's added a new behaviour in the future might not be doing TDD data school.
Do you find it takes twice as long?
Sorry?
Do you find it takes twice as long?
Actually, it takes less time. Because on an average task, you might end up spending a lot of time debugging or reasoning about your code. But it might slow you a bit on the very short term, but there are a lot of longer term things. Especially when your code gets much more complicated and you keep adding features to it, then you need some sort of assurance that you're not breaking anything. What if, for example, you're doing a major design change? How will you make sure that your code is still producing the same services that it used to? Right?
Does that mean that the TDD has been named wrong and it should be design driven by test?
Well,
You're not testing the design, testing the development.